Okay, I believe I already did a video for this first 7, but I'm going to do it really quickly. Which measure is equivalent to the measure of 160? If you want radians, you have to do pi over 180. The zeros cancel. Right now you're left with 16 pi over 18. 2 goes in the 16 8 times, and 2 goes in the 18 9 times. So it is C. Number 2, they want you to draw a 210-degree angle, which is about right here. Draw a terminal side, and you're going to draw a right triangle with a vertical side to the closest x-axis. Put in a 90. This is O. This is C, and it says let OC be 5. Since it went 210, this is 180. If you went 210, this reference angle is 30. So this is a 30, 60, 90 triangle. So this is the short leg over here. This is the long leg, and this is the hypotenuse. So if this is the hypotenuse, the short leg is half of this. So this would be 5 halves, but it's negative because it went down. And the long leg is always radical 3 bigger than the short leg, so it's like that. And so it'd be negative 5 radical 3 over 2. Oh, down, and the y-coordinate's going to be negative 5 halves. So it's not this one. That one could be it. It's not this one. The y-coordinate had to be negative 5 halves, so it has to be C. Which is equivalent to this, sine of 5 pi over 3. 3 means it's a 60. The 5 in the top means 5 times 60, so this is a 300-degree angle, which is in the 4th quadrant. Another way to do this, you can think of this as 3/3, and this is 6/3, so 5/3 has to be in the 4th quadrant. Okay, so anyway, we're in the 4th quadrant. So sine is negative, so one thing we know is that's negative. And the sine of a 60. 60's ordered pair looks like this. So the sine of that is this. So I'm looking for a negative radical 3 over 2, which is C. Looks like C is the popular answer right now. What is the exact value of this? Cosine of a 60 is 1/2. It's in the 2nd quadrant because that's 2 60s. That's 120. So this is really 120 degrees. So cosine of a 60 is 1/2, but it's negative. So right now we're looking at negative 1/2 plus the sine of pi over 6 is also 1/2, but it's 1st quadrant. So this answer should be 0. B. Which describes the location of vertical asymptotes of tangent? Well, tangent's undefined at 90 and 270. Okay, it's the vertical. That's when tangent's undefined, so that's where your vertical asymptotes will be. So you're looking for something that's always going to be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So this is all pi over 2 n's where n is odd. So here is pi over n2, but that doesn't say that it's odd. So it is not this and this. This is how you represent an odd number. Like for example, if I let n equal 0, that would be 1/2. If I let n equal 1, that would be 3 halves. If I let n equal 2, that would be 5 halves. This represents odds over 2. N. Is that an n? Is that a pi? Oh, there's the n. That's pi. So it's D. So if the answer in the back says B, it's wrong. It's D. Which amplitude shows the amplitude and period of this function? The amplitude is 2. And the period is always 2 pi over B. So it's 2 pi over 4, which is pi over 2. So the period's pi over 2. Amplitude 2, period pi over 2. Looks like B. And the graph of this is shown. What is the equation of the function? Well, I'm seeing a cosine right here with a period of, this is 2 pi, this is 3 pi, so it looks like the period's 2.5. Looks like the period is 2.5. So to get B, you'd have to take 2 pi over 2.5. So this is the non-calculator, so let me think of this as a fraction. 2 divided by 5 halves. Invert and multiply. That'd be 4/5 pi. So that's going to be your B. So which one of these have 4/5? So it's not A or B, so it's one of these. It looks like the vertical shift, it goes from, what is that, 3 to 4? Is that 3? 3 plus 4, 3 plus negative 4 divided by 2 is negative 1/2. Did I not do my, is that 4? Was that a 2? Oh, I'm sorry. This is a 2. Can't read that. This is negative, okay. So this is negative 2 over 2. So that's negative 1 vertical shift. So both of them have that. Here's that. These are very similar, except one's negative, one's positive. I'm going to say that it's the positive because this is a regular cosine, high to high. So it's got to be the positive. If it was a negative, it would be like starting here, and you'd have a phase shift. You'd be on like here. This is the negative, the low to low, but you'd have a phase shift, and there's no phase shift there. So it's D. All right, so I think I already did a video for these, but I did not do a video for 8. So this is where I'm going to start getting a little bit slower. What is the range for the arc sine? Okay, so arc sine, there's 2 ways you can think of this. Sine is positive here and negative here, so it goes negative pi over 2 to pi over 2. But that is your range. That's important to know when you're getting your answers. What is the value of this? So why did I want to ask you this? What is the value when it's negative? Negative means it's going to be in this part of the quadrant right here. So you're going to be negative 45. That's negative 45. That's why they ask you number 8 before they ask you number 9. 10, what is the solution to this? Basically, it's saying what angle has a tan value of radical 3 over 3, and it's positive. So tan also does the same thing as sine. This is also tan's range. So we're positive, so we're in this quadrant. So tan is there at 30. 30. To define inverse cosine function, which restriction placed on the cosine? Now, cosine's different. Because of cosine being positive here and here, we don't go negative 90 to 90. We go 0 to pi. So the negative value is going to be over here. So in cosine, it's 0 to pi. Actually, so cosine domain is 0 to pi. The inverse, okay, so inverse cosine function's range is 0 to pi. But cosine function's domain is this. So they said define the cosine function, not the arc or not the inverse cosine. So this range is 0 to pi. This domain of cosine is 0 to pi. But we're looking for 0 to pi. So what is the value of arc cosine? So we are looking at the range. So I don't know why we asked that question. The range of cosine is 0 to pi. So any positive value, your answer is 0 to 90. Any negative value, the answer is 90 to 180. So this is a negative, so our answer is between 90 and 180. Cosine is radical 3 over 2 at 30, but you're in the second quadrant. So if 30 is pi over 6 over here, this one would be 5 pi over 6, and that's your answer. What are the general solutions for this problem? So there's no GCF in this problem. It's not a trinomial. So you can just solve this one. We're going to add 1 to the other side. You can't do this if it's a trinomial, but you can do this if it's a binomial. Divide by 2. Square root both sides. So you're going to get sine x equals plus or minus square root of 1 over square root of 2. We are going to rationalize, and this is going to be radical 2 over 2. If you take the arc sine of each side, it's going to be arc sine of all of this. So what angles, it says general solutions, have a sine value of radical 2 over 2? It's all the 45s, all the way around. First quadrant, second quadrant, third quadrant, fourth quadrant. So one way, the long way to do it is to say pi over 4 plus 2 pi n. 3 pi over 4 plus 2 pi n. 5 pi over 4 plus 2 pi n. 7 pi over 4 plus 2 pi n. So that's one way. That's a long way. Since 45s actually are every 90, like this is 45, that's 135, they're 90 apart. 225, these are 90 apart, and these are 90 apart. Another way to do this is pi over 4 plus pi over 2n. That means every 90. It's pi over this one right here plus every 90. You just keep going around. This is a short way of doing it, but I would accept this. What are the general solutions to this? This is a binomial, but this is different than this binomial. This one had a single number, so I could just solve. This one's got 2 terms that have cosine in them, so you should take a GCF out. So if you take a GCF out, it looks like this. Then set each factor that contains an x equal to 0. So this one's going to be arc cosine of 0. When is cosine 0? And it says general solutions. cosine is 0 here and here. So you would say pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n, or because these are 180 apart, you could say pi over 2 plus pi n. General solutions. That's 90 plus every 180. Okay, but I'd accept this as well. Now, the second part is cosine x equals -1. So we want arc cosine of -1. When is cosine -1? That's only one place. That's at pi. But it's general solution, so it's pi n, where n is odd. If you wanted to actually show odd, you could go 2n plus 1 pi and not write where n is odd, because that means n is odd. That represents every odd number in the world. So you could do this, or you could say pi n where n is odd. That's general solutions. This one says just 0 to 2 pi. Now technically this equal sign should not be here. This should be 0 to x is less than 2 pi. So in other words, 0 bracket, 2 pi parenthesis. That should be your directions. So this, in other words, it's radians. How many terms do you see? I see 1, 2. If you have 2 terms and one of them is not a single number, you have to do a GCF. So let's take a tangent x out of both of these terms. If you take tan out of tan, you get 1 minus 2 cosine x. Take a tan out of both terms. Set each one equal to 0. So when is tangent 0? That's at 0 and pi. On this one, 1 equals 2 cosine x. Cosine x equals 1/2. When is cosine 1/2? Cosine is 1/2 at 60. And in the fourth quadrant, so if this is 6 over 3, this would be 5 pi over 3. That's the fourth quadrant. There's your 4 answer. Draw each graph for 1 period. The amplitude is 2. Horizontal shift. We have to factor out a 2 out of this problem. You cannot do this problem while this 2 is still inside there. So factor out a 2. So this horizontal shift is pi over 2 left. Your domain is all real numbers. There's no restrictions on cosine or sine. The period is 2 pi over the 2 right here, which is just pi. The vertical shift is 3. That's this number right here. And the range is going to go from the vertical shift. Let's just get this graph ready. The vertical shift is 3. I need I need a red pen or something. Where's my red pens? Let me find this. All right, I see a red pen. All right, so the vertical shift is 3. And the amplitude is 2. So my range is 1 to 5, low to high, including 1 and 5. All right, so we've taken care of the vertical shift, and we've taken care of the amplitude, although the amplitude is negative. So I have to remember that this is inverted. This is an inverted cosine. Inverted cosine goes low to low. Keep that in mind. Inverted cosine, because of the negative, is low to low. So we have a period of pi, so I have to fill this in. 1, 2, 3, 4 is pi. Since we're going pi over 2 to the left, I might want to go 2 more hash marks either way. Because we're going to go pi over 2 to the left, and pi over 2 is 2 hash marks. So if we did an inverted cosine, but know that it's pi over 2 to the left, I would typically start right here, low to low, and I would end here, okay? Start here, end here, but I'm going to go 2 pi over to the left. So I'm going to start it here, and it's going to end in 4 hash marks, 1, 2, 3, 4, so it's going to end here. So in the middle, it's going to be at its high, And at pi over 4, negative pi over 4 is going to be at the mid, and at pi over 4 is going to be at the mid. So this is an inverted cosine that has been shifted pi over 2 to the left. If I wanted to continue this, I'm going to have another point here, and this one's going to be here. So that's what it looked like if you went negative pi over 2 to pi. If I wanted to continue drawing these, this would be 5 pi over 4 and 3 pi over 2. So I could continue doing this and end it right there. So it depends how far you want to go. It just says draw each graph for one period. So for me, one period would be like right here. All right. This one. Period is, okay, we have to factor out a 3 again. But this time, if you factor out a 3, this becomes pi over 6. Because pi over 2 divided by 3 is pi over 6. So the period is 2 pi over 3. So this is 2 pi over 3, which by the way is 120. So this is 60, which means this is 30. So 1626, this is 3646. The vertical shift is -1. Amplitude is 1, so you're not going to go any higher than the 0. And -2. Actually, since it's cosecant, you're actually going to be higher than this and then lower than this. Your domain, you will have some restrictions here. To do these first. Horizontal shift is going to be pi over 6 to the right. I'm going to save the domain and range for when I graph this. I'm going to go ahead and graph sine of this first, and then I'll do the cosecant because I'm going to do the sine really light. I'll do really, really light. So a sine would start at the mid and have 3 zeros. It'd be a high and a low. So this is what your sine would look like. Okay. Your cosecant is going to have asymptotes wherever this hits 0. And then where it's high, you're going to have this upper parabola here. And it's going to be down here. Okay. So your domain, it looks like all numbers except pi over 3 and 2 pi over 3. It looks like every 60. So all reals except, looks like pi over 3n. Where n is, this pi over 3n, because n would be for every integer, so pi over 3n. The range is, looks like negative infinity to this -2 line, in union with, and it starts again at 0 to positive infinity. That's your range. So she's got it. Oh, did I not do a horizontal shift? Oh my gosh, guys. I didn't do a horizontal shift. Look, I forgot the horizontal shift, pi over 6 to the right. So all of these have to be pi over 6 to the right. So if I redrew this, if I moved this asymptote pi over 6 to the right, the asymptote's now at pi over 6. Crap. Oh, that means every point's been pi over 6 to the right, so that's going to go here. So at pi over 3, I'm going to have the up part, and then moving everything over pi over 3. So if I move my next asymptote over pi over 3, pi over 6, I'm sorry, it'll be at pi over 2. So this is pi over 2. So 2 pi over 3 is going to be the down part. All right, so how does this change our domain? It changes our domain for sure. Everything, all these things are the same, guys. The range is the same. The only thing it changes is the domain. So your domain is all reals. I forgot to shift this. it's at pi over 6 and pi over 2. So this is 1/6 and this is 3/6. Pi over 2 is really 3/6. So it looks like all the odds. So it's pi over 6 and where n is odd. It says here where n is an integer. I just don't think that's right. So if k was 1, look at the answers here. That would be 1/6, but if that was 2, that would be 1/3. That's not true. This would have to be, and the answers here would have to be odd integers. And I'm not crazy about this range either. The range is not to -1. The range is to -2. And then this is 0. So I disagree with this answer. I disagree with this answer. So I think the range is -pi to -2. And union was 0 to pi, to infinity. That part did not change. The only thing that changes was the domain, because I did not shift pi over 6 to the right. So this is the other graph. Pi over 6 to the right. And this is 2 pi over 3. So you should have it down, the low at 2 pi over 3 right here. The high should be starting at pi over 3. Okay. You probably are more confused now. Continuing on. Okay, the calculator part. A 40-foot ladder is leaning against the building. The bottom of the ladder is 32 feet from the building. Find the angle that the ladder makes with the ground. We're finding the angle of elevation. So this is your adjacent side, and this is your hypotenuse. So you want a cosine of angle is 32 over 40. So our cosine of 32 over 40, we need to make sure that we're in degrees. So let's do that. I am. So it's arc cosine of 32 divided by 40, which is 36.9. I'm switching back to my pen. An airplane takes off 600 feet in front of a 50-foot building. Takes off 600 feet in front of a 50-foot building. Takes off 600 feet from there, this 50-foot building. At what angle of elevation must the plane take off in order to avoid crashing into the building? He wants to make sure he clears this. So we would want tangent. Tangent of theta is opposite 50 over adjacent 600. So this is going to be arctan of 50 divided by 600. 4.76 degrees. So about 4.8 degrees. That should be the angle of elevation he takes off from. Find the exact value. This means no decimals. What angle has a tan of 1? 45 degrees. And what's the cosecant of 45? Well, sine of 45 is radical 2 over 2. So cosecant of 45 is 2 over radical 2, which if you rationalize, the 2's cancel and you get square root of 2. This one, what angle has a cosine of radical 3 over 2? 30. And what's the sine of 30? 1/2. Sine of 4 pi over 3. Sine of 60 is radical 3 over 2. 4 over 5, this is negative because it's in the third quadrant. So you have this. And what angle has a sine of radical? You have to remember that sine has this range. So if it's positive here, it's negative here, so you're going to be in the negatives. When is sine negative radical 3 over 2? That is 60. So you'd say negative 60 degrees. This one you're going to have to factor. 3 tan x tan x. Factors of -2. We want this to be -5 here. So let's put the -2 over here. That's -6. And the positive one here. It's a -6 and 1 is -5. So 3 tan x plus 1 equals 0. Tan x minus 2 equals 0. This is tan x equals negative 1/3. This is tan x equals 2. So you're looking for this and this. Now, starting with the negative 1/3, tangent is negative. Let's do this. Tangent's negative here and here. But to get these answers, you're going to have to punch this in the calculator. The positive 1/3.
I keep hitting the 0 to 5 on my outside, but I'm doing it. I don't know if it's just not.
We'll look later. Come after school, before school to go over that. Tangent of 1/3 is 18.43. Oh, am I in degrees? So this is 18.4 degrees, but we want second quadrant, so you're going to do 180 minus 18.4. I'm just going to go up and highlight this. 161.6. That's one answer. And then the other one's in the fourth quadrant, so you have to do 360 minus this angle. For 341.6. That's two of your answers. And then tangent of 2. So do arctan of 2 is 63.4. That's one of your answers. Because it's in the first quadrant. Tangent's positive there. And then tangent's positive in the third quadrant, so you want to do 180 plus that. And you get 243.4. So those were 4 answers. All right, I'm going to continue this. Oh my God, you can't see any of that. I'm going to continue this in a bit.